So first of all, thanks a lot for being here, having the possibility to explain you what and how the low flash point supply system looks like. So from an Alfa Laval perspective, this is actually what we are now supplying on the market for the marine industry. So participating to the development of this technology was for us an opportunity to create a further occasion to serve owners in choosing their own fuel. So it was not for us to choose one fuel in particular, but to create solutions for every possible fuel on the market. So it was 2013 when we were developing the EGR water cleaning system that we had the opportunity to start also the development of a fuel conditioning system. This is how we in Alfa Laval call this kind of equipment for methanol fueled engines. No? And MAN and the industry calls them LFSS, low flash point fuel supply system. So how this system from 2013 looked like, this was the first generation of systems. No? So it is a system comprised by two steps in the process, one low pressure system and one, which this is the low pressure step, and one high pressure step, much more looking like a conventional booster system that is used for heavy fuel oil and marine gas oil. That was our approach on this application when we started. So looking like, okay, creating a process which was the most reliable for a new technology in order to know well what could be the limits and focus on the new technologies and components that should have been brought into marine industry from many different other industries, no, like oil and gas and so on. And then this system was controlled by a control system based on a touch human interface that should have been placed in a safe area, while the entire fuel conditioning system was installed into the deck house. So this is what we have delivered so far. 9 units, 2 test units, one in Copenhagen here, the very, very first one in Mitsui for their own test engines, and then we supply the entire fleet. And we are now preparing to deliver the 4 new units for the new orders, and we are going to deliver them from an Alfa Laval site in Italy, in Monza, from September this year down to December, 1 per month. And okay, process-wise, I mean, we are obviously matching the control and the process requirements of the engine. Therefore, we have given the engine is a 6G60, so we are providing 3,000 kilograms per hour through a 2-steps centrifugal pump based system, which is actually pumping 10,000 liters per hour. So we kept the process like a conventional booster with a recirculation factor for this generation of systems. So what is Alfa Laval's scope in the fuel line for methanol is what is comprised into the yellow rectangular. So from the daily tank or the deck tank, we are isolating this process that is made by 2 steps, so low pressure up to 6 bars, and then the second pump will deliver the 10 bars required to the engine. And the last step is a filtration step by static filters, 10 micron, and then we end up with our second insulation valves. What you don't see where the nitrogen comes in, but we are comprising nitrogen, and then we have the 2 lines, the deaeration and drain line. So it is a fully enclosed system that is automatically driven, from taking control from the engine and from ECR. So this system is basically transparent to the operator during normal operation, and it has fully automated routines for startup and stop. So the operator must not go on the skid to open valves. Everything is controlled by the safe area installed control panel. So at a glance, in 3D, this is how it looked like. And from design point of view, we could optimize it much, both in space, so reducing the footprint, and process-wise to reduce the number of piping, so improving the purging and improving the speed by which the system is brought up to, let's go from stop to standby, so reducing the time. And today, the new, let's say, supply that we are going to provide from September are now with an improved design, and we have also invested into dealing with the yard for a better integration with their own installation. So we started from where this system will be installed, and we designed it to be well integrated inside the deck house and be more friendly for the next step of the process, which is the fuel valve train. That is not inside our scope of supply, but we know that is exactly in front of our system and will be installed like this. So this is how it will look like, this new generation. It has been improved in many areas, maintenance-wise first, and then also from vibration point of view. We have now lowered down we have learned from what we have done so far, and we have lowered down all the lines and making more robust. And one important new feature that we are going to spec in the process will be the possibility to clean the filter chambers independently. We learned that methanol can be dirt in some way, taken from the tanks at least, and therefore you really need to filter it down. So these 10 micron filters were getting clogged, and from operator point of view, we had to solve how to not stopping the system to perform maintenance. So initially, today's generation still has to be stopped, and then you have to purge it. So you are losing time, and you are consuming nitrogen, and you are not running the engine with methanol, but you have to run it with gas oil. Then you have to open the filter, and then you can perform your maintenance, just, let's say, removing the basket filters, and that's it. Today still, filtration is an accumulation process, so you cannot have automatic filters. They are not available. We also in Alfa Laval have an automatic filter, but it is yet to solve how to, let's say, have the process done without having loose opening ends and so on. So how to deal with vapors in automatic filtration, whatever kind of style you want to adopt in automatic cleaning of the basket filters. So what we ended up with so far was to use a double block and bleed installation. Therefore, you can switch to the standby filtering element, and then you can, in this case actually, in the new generation, you manually purge from the site the candle or the insert that was on process up to that moment, and then you can safely open the chamber, take it out, and then replace it, and then let's say restore a standby filtering element in this without the need to stop the system. Another important feature that we added is, but this is belongs to MAN also, requirement and control. We can now stand still after operation. So instead of every time purging the system and going to an empty system, which actually takes a lot of time, then when you have to purge it again, fill it in, let's say reach the right pressure level, and then restart operation. Now we can have a more flexible behavior, which means that if you have a minor issue, you can just stand still and wait for this issue to be fixed, and then you start again. So we are improving and improving. And in parallel with this new generation of methanol, we had the opportunity also to develop and deliver the first R&D test unit for the LPG engine. And from control point of view, from our side, these two control systems will go soon together. So we will have the methanol that will be upgraded from control and process to the style that will be adopted for LPG. So LGI engines from our fuel gas system or LFSS point of view will be basically the same, changing the pressure ranges and the technology of the components, but the control philosophy and the process will be basically the same. So now we have optimized the design, we have optimized, let's say, we have fixed what so far were our faults and the process-related difficulties. Now we will improve the control and we will improve the energy saving to what is LPG standard, which is higher, given also the process is more demanding. No? That's it. One important last point was we have an extensive experience in the marine business, and we had 3 different distribution centers in the world to, let's say, handle spare parts. And usually our standard is the capability to deliver spares around the world in 1-2 days. That was definitely not the case for this application. And we suffered a lot. We made the owners and also many times wait for spares. And what we have done so far now is to create a dedicated warehouse in Sweden. So also for this kind of application now, no matter the volumes we are generating or whatever, we will have spare parts there. And this is available now. So we can, let's say, uniform spare parts for this niche or very small number of units to what else is the market demands. So, and that's it. Done for me. Any questions? Yes?
Why do you have heat exchangers in it? Do you heat up the methanol, or is it to get rid of the heat process?
You also, and this is common also to LPG, no? You do not know, you need to deliver methanol at within a certain temperature range. So it could be lower or higher, and therefore you have to adjust the temperature. So still today, I mean, we are using shell and tubes. In the future, we will move to plate heat exchangers, which is more natural and compact. But then you still need to adjust temperature. Let's call it instead of, we are not recovering heat, or we are not in some way saving some heat. Is that it can be lower than 0, also depends on what are the ambient conditions. No? Please?
Which impurities can cause problems for the engine?
What we found in the baskets, you mean?
Yeah, for example.
Yeah, I mean, I think that were initially a lot of debris that were from the ship manufacturing, so perlite or a lot of solids like this. I know about other issues regarding oil contamination of the methanol coming through the system, but that was not really related to how dirty the methanol could be, but it was more like related to how you separate the oil that comes back from the engine into the daily tank. So the tank should be properly built by the yard in order that this separation comes naturally and you do not pump the oil back to the system, because then you can create emulsions, and then in some filter size, let's say element geometry, this emulsion could just block the filter element, no, and create this. But oil is now in something of the past, and debris can always happen. I think that then it will always be the matter of, if we are talking about a cargo ship, so a tanker, or a methanol fueled ship. Probably when you will have dry bulk carriers, methanol fueled, that methanol will be less dirt inside than a tanker. But I think also, I mean, is experience with other fuels that when you have the tanker, then it could be a little bit more dirt. Taking at least initially what is the dirt from the yard, let's say manufacturing installation. So not really something specific that belongs to the methanol. It's probably how it is pumped and handled. But anyway, that was, let's say, useful to see that really need a filtration system. Unfortunately, I mean, we discussed with many makers, and yet they know, no, they are sizing for the gas application. No? So you take these filters from what is already okay for high pressure gas engines or low pressure gas engines, and they adapt for methanol, especially the gaskets and so on. So it's not really dedicated to methanol yet, no? But it will come with the volumes. No? So we can then save down also in that. Any